Welcome back, everybody, to this edition of this is probably our third or fourth video podcast, I would say. And it's going to be, I have a great pleasure of introducing to y'all Kevin Sides. Let me give you an introduction to Kevin. Kevin is the sales manager for the George Israel Company for the past 6 years, I think, almost 7 coming up, and has had extensive background in the HVAC and plumbing world for over 25 years. So I can't think of a better person to have a conversation with. Our topic today, pressure boosters. And we're going to talk about a few things. Now, where Kevin's located is in Florida, so we may talk a few things around Florida and maybe even pick around with it. But let's start off with some of the basics, because I think this is going to be kind of important. And some people out there may not even know what a pressure booster is, because maybe they didn't have the application for it or what. So why don't we go through the very basics first, and we'll get into some of the nitty-gritty. What are they? Why are they needed? What's important about them?
Well, I mean, a pressure booster is just a simple pumping package that you can put in your building to increase the pressure coming into the building. For example, if the city's only giving you 30 pounds of pressure and you need 65, our pressure boosters will make that other 35 pounds available to the building.
So this is all on the domestic side for fresh water, basically.
Yes, this is domestic water. There's also other applications where in South Florida we're using them for cooling tower makeup, where they're bringing all the condensate from all the water source heat pumps back down to the basement, collecting the water there, and then pumping it back up to the cooling tower for makeup water.
It's almost like a water conservation thing.
Yep.
Interesting. I think I've seen a couple of those things for some lead stuff. So, well, that was a good example, because my next question was going to be, all right, I used to live in Florida. I live in the Carolinas now. We go and do this, and I'm thinking of Florida. Florida's flat. How many buildings can there be that need a pressure booster from the city? I mean, probably more than I'm thinking.
Yeah, Florida's flat, but we're also crowded, so you got to go up. So every time we go up, that means pressure drops, and they need more pressure to the building. So pressure booster packages come into play.
So help me out with this one. With this piece of equipment, it's a package, right? I mean, there's usually 2 or 3 pumps on there, and so what are some of the common misconceptions that people don't realize when it comes to boosters and putting this on the application or applying correctly?
Well, the biggest thing about a pressure booster package is, for some reason, people thinks it increases the flow. We can't make more flow. We can make more pressure, but we can't make more flow. So they'll think that if there's only 30 gallons available, they think for some reason I can make it 60 gallons, when that's not the case. So
you just increase the pressure like a pressure washer is what you're saying.
Right. And they also think if I put in a bigger pressure booster, it's going to help problems that they may have. And, not considering old buildings that have, pipes that used to be 3 inches in diameter on the inside, and now they're 1 inch because of all the buildup over the years. So, yeah.
So sometimes it's the application then. True. I mean, it may not be the booster's fault that it's doing what it was designed, but the piping sucking water through a coffee straw versus a regular straw, and you got some issues.
Absolutely.
That's interesting. And obviously you don't have that many old buildings down in Florida, right?
Oh, yeah. Yeah.
Well, I want to get into this one, and this is an interesting one for me because I've done a little research on it. And, there, to my knowledge, and correct me if I'm wrong, boosters are designed around a certain set of assumptions. And the term that I saw and I looked up and I want to get some clarification on is the Hunter curves. Understanding those, how old are they? I've heard some rumors they're fairly old, and are they still being used today, kind of thing?
So they are actually still being used. They are being used today. It was actually came up with by a man named Roy Hunter back in 1940 for the U.S. Department of Commerce. And what he was doing was he was creating curves that were based on banks of toilets and their GPM flow, and the same for laboratories. And because each fixture has a different flow rate, the Hunter curve converted them into a common value or a fixture unit, and then those fixture units were placed on his curve. So you could, it was an easy way to go size a booster selection. If you had 100 bathrooms, you could look at the chart and kind of figure out what your flow needed to be, and those type things. The problem is, back in 1940, when he designed these curves, the flow rate for, just say, a toilet was 5 gallons per flush. And today, and even back then, the downside to his curve is that it was very conservative and that you were probably oversizing. So you go back into today's market where the toilets are 1.2 gallons per flush. So
almost
now,
half.
so now there's even a bigger chance that, if designers are still using the old curves, the systems are way oversized. Now there is a movement out there to redo the Hunter curves. I think it's just a matter of which organization is going to take the bull by the horns and do it. I know that ASHRAE has a modified one.
Mm-hmm.
I don't know a lot about it, but I do know they have worked on a modified Hunter's curve, which kind of took some of those into consideration for the new flow values.
Right. And maybe ASPE. I would imagine ASPE's probably looking at some of this stuff too, maybe.
Yep.
Yeah. It's interesting to think about if it was oversized that long ago, the systems have to be significantly oversized. So there's probably if you're looking at a replacement of a booster system for any given property, I gotta think, is it a good opportunity to look at and maybe possibly downsize to a smaller one where you don't necessarily need all that?
Yeah, so absolutely. So whenever we have a customer call, first thing we look at the old pressure booster, what was it sized for? And then we go back and we look at their flow. And, I'm kind of going back to the Hunter curves myself.
Mm-hmm.
How many units are there? And we're calculating the real flow. And, you kind of have to ask them a lot of questions. And most of the time we come back to where we go back with a smaller booster package. Maybe, if it used to be 7.5, now we can do it with a 5 horsepower. Most people don't want to do that because they think that we're giving them less of what they had before.
Sure.
So we give them the same system, but then we switch them over to variable speed. And that way, if demand, in the middle of the night, if the demand's very low, you've got one pump running at a slower speed versus the old constant speed systems. You got one pump running full bore, doing everything all it can do. Yeah.
So on those variable systems, the good news is if you're doing usually more than one pump, I would imagine that's kind of a little bit of a backup, or it could be set up that way too.
Right. And today in most booster manufacturers, a constant speed pressure booster is a highly engineered product because nobody makes them anymore. I know Gossett doesn't make one anymore. Everything's variable speed. And I'm glad for that because the biggest headache for maintenance in the constant speed system was the PRV. They were constantly one little nick in the diaphragm and you're, rebuilding the PRV kit, or if the pilot valve gets off, somebody gets in there and messes with it, you're having to rebalance the whole system.
Sure. So it's worthwhile most likely to look at, if you have an opportunity that is a constant speed pressure booster, obviously you'd advise to go and make sure and try to budget within the next, probably 5 years or so, I'd imagine, because it sounds like these systems can require some maintenance and can go down. If they do, it's more of a headache to deal with the repair than it would be to put one on order. And I'm assuming getting them there's a decent amount, or significant, I don't want to say significant lead time, but it's a decent amount of lead time to try to get one.
Yeah, there's some manufacturers out there who actually have them in stock. You just have to work your way. You have to pick the one that's going to fit that application best. Sure. Normal lead time is 4 to 6 weeks, but it's the condo association who's waited till the last minute to open the pocketbook and spend that $15,000 for that new pressure booster.
Sure.
And it goes out on a holiday weekend. And, those are the guys that usually wait too long to replace the system.
Yeah. This seems like one of those ones. And to your point, it seems like a last minute, last thought, right? But I get the feeling this is something that it should be easily budgetable. And you think about it and knowing as part of a broader maintenance plan. And this kind of leads to one of my other questions, and I've heard this in the past too, is, because it's dealing with potable water, right? I've heard that, all right, if you have a large building like this and, obviously we're trying to get water to those toilets, to the urinals, to the sinks, to the showers. If the pressure booster does go down, like you just mentioned, I've heard, in commercial properties, sending people home because there's no way of flushing a toilet. Does that sound right? Is that true?
It could be, but it all goes back to the design. In most new applications today, when boosters are being designed, because the prices come down with variable speed, A lot of times on a duplex package, one pump can handle the load and you've got a second pump as a standby. The other option is if it's piped in properly, there is a bypass between the suction and the discharge. So you could turn the city water on. You at least have city water pressure. Even though it may not be a lot, you would have something, where people could come down to the lower floors to use the bathroom if they had to, and not have to shut the building down.
So a little bit of a makeshift, yeah.
Now, if there's a complete electrical failure to all the components of the booster, then, that would be about the only possibility where you have to evacuate the building.
Like a lightning strike in Florida.
Yeah, that never happened.
That never happens, I can imagine.
Never happened.
Yeah, so how does that compare to, say, a constant speed booster versus the variable one that you were just mentioning? It sounds like you have some variability and a little bit of backup with that variable one versus, say, the constant speed, maybe not so much?
Well, the older systems, you did have some redundancy built into them, but, most of the time you were splitting the flows equally. For a duplex, it was 50-50, just because of the size and the amp draw of those motors at that time. But it's the same thing. Most of them had electronics in them. And like you say, down here in Florida, if they get hit by electronics, you're dead in the water.
Yeah. So speaking of that constant speed and the variable one, and obviously older buildings, and then it's not just, Florida, obviously across the entire United States, from the whole East Coast of New York to even out in the West Coast, there's plenty of old buildings out there, obviously, and need to get some of these pressure boosters replaced. Is there an ideal time to get one done? And, I get a feeling there's a payback, obviously, with the price coming down with using variable speed versus the constant speed in the application.
Yeah. So the optimal time would be to replace it before it fails, as we spoke to earlier. Really, it's, give yourself that 4 to 6 weeks, have a good contractor. Most contractors, most plumbing contractors who do this on a regular basis are used to coming in at 7 p.m. that night, and by the time you wake up at 5 a.m., it's running. So most of them are prepared for that. There's so many contractors now who can pre-pipe stuff at their shop, so all that's already done when they hit the job site. With plumbing now, you got the Pro Press, you've got the coupling type connections. You're not having to do all that soldering, so it is a lot quicker. And then with the packages, we have the options of having flanged headers or the coupling type headers. So it makes for quick connections to them. And there's been many 3 a.m. startups that I've done. So I know that they're there.
That sounds enjoyable.
Yeah. So,
well, I know in Florida that most and listeners that would be listening to this or watching this as well in Florida will be able to contact George Israel for getting any of those pressure boosters replaced for sure. What about across the U.S.? What kind of opportunities are there?
Well, there's the whole FHRA network, all the Bell and Gossett reps, highly trained people who do this every day in the Bell and Gossett community. And again, the different broad range of offerings that Bell and Gossett offers with their variable speed pump packages is just tremendous. The new EMT package that's out, it's the best one they've ever had. I can dial that thing in to do just about whatever I want it to do.
That speaks a lot, just to make sure that's ease of maintenance and dialing it in, as opposed to in the past. I've heard some stories, not just Bell and Gossett, but boosters in general, when it was older, of getting that fine tuning was a challenge.
Yeah, I spent many days banging my head against the wall for a on-off pressure switch. So, yeah. And the nice thing is we sell a lot in the Caribbean as well, where we're doing lift applications, and, our packages just work awesome in all those different type applications.
Yeah, it's great. Just thought of one other question I want to ask you, because I was thinking about this. Do you see with this big push for obviously green and energy efficient buildings that we're going to start seeing maybe a potential for dual systems, maybe on the gray water application, kind of speaking a little bit of what you were doing with the cooling tower? I get a sense that there could be more booster from a water efficiency standpoint for commercial buildings.
So yeah, I do see the gray water eventually coming into play, which will have, like you said, that'll be another whole different package. There's already a market out there for the gray water business.
Okay.
It's kind of moved slow. I think just because you still have to treat that gray water to a certain extent on what you're using it for. But yes, I could see it where they're bringing the gray water in to flush toilets and that kind of thing.
Yeah, I can see that too. There's always been that challenge I've always seen about it. When you use gray water, you got to have it's almost a secondary plumbing system throughout the whole building, which is interesting.
Gray water, rainwater. People use rainwater now collection for irrigating their lawns. So you see a lot of that as well.
Yeah, it's pretty popular down in Florida as well, I think.
Yeah, got to have the green grass.
Wow. Well, Kevin, thank you so much. I mean, this has been very insightful. I really enjoyed the conversation as well, and learned a little bit about booster systems, and would love to have you back on for another topic.
Yeah. Come down to Florida. I'll take you to see Carol Baskins.
I appreciate it. Thanks, Kevin. We'll talk to you soon.
All right. Talk to you later. Bye.